The Sustainable Hydrogen Cooking Gas Project is a research undertaken by the University of Technology, Jamaica, Faculty of Engineering and Computing, and is funded by the European Union. It is specifically geared towards looking at sustainable development, poverty reduction, cheaper and cleaner energy, and how it can be produced to enhance the quality of life of the Jamaican people and, by extension, the world.
The project is an important one for the University of Technology Jamaica because it is one of the few research projects that are happening in the area of renewable energy. This is the first time in the history of the University of Technology that we are leading such a project. The aim is to produce hydrogen at a commercial level so that it could then someday in the future, perhaps in 5 to 10 years, become a substitute for the imported liquefied petroleum gas, LPG, that is used by most households in Jamaica, as well as the rest of the Caribbean.
The beauty about hydrogen is that it's the most abundant element in the universe. The drawback, though, it doesn't exist on its own. So you have to find ways and means to get it from the source that it is. Comparing it with LPG, it has 2.5 times the energy content, pound for pound or kilogram for kilogram, as LPG.
The solar hydrogen project is powered from solar energy. So the system is comprised of the solar panel. We have a charge controller that manages the charging of our battery bank. We have a total of 6 batteries, and our output DC voltage is 24 volts. That is converted by our inverter to 220 volts to run our electrolyzer that actually generates the hydrogen.
Okay, so from the electrical side, you saw the equipment in the battery room, the inverters, and the batteries being powered from the solar panel. Now from there, no electrical power is sent over here to the electrolyzer that we have here. So this is the actual piece of equipment that converts the electricity into the hydrogen. And it does so by splitting water. So it splits the water into the hydrogen and oxygen. The oxygen is vented to the atmosphere and we capture the hydrogen and store it. Now here we have a setup showing how the cylinder here with the hydrogen will be connected to your stove. And as you can see, this is more or less a normal stove with some slight modifications. Right, so the modifications are necessary so that the stove will be able to burn the hydrogen.
Today we'll be preparing curry chicken using hydrogen gas as opposed to LPG.
The major concept behind why we look at this study is right now Jamaica and most of the Caribbean, those without oil, are importing oil. To use hydrogen via sunlight and water would eliminate the need to import that component of fuel in the country. Also, it should reduce deforestation if we can get it cheap, so somebody would need to burn trees for coal for cooking. But this product would be locally produced.
The government has an important role to play in facilitating the furtherance of this project beyond this project life. In that, we have reached a stage where we have shown that it can be feasible to use hydrogen gas generated from water and using solar power. We are not short of solar energy in Jamaica. The National Energy Policy of Jamaica makes mention of hydrogen as an energy diversification source. The work that has been done here at the University of Technology Jamaica is seminal to the growth of a hydrogen economy in Jamaica. We believe that with more work in this area, we have a real opportunity to diversify our imported fossil fuels to gas that is produced by clean water and solar energy.
The top achievement of this project, it was on two fronts. One, what to do with a local stove and what to do with hydrogen gas. The hydrogen gas is known for many years how to produce it. So that was not a big issue. The major issue was to use it though domestically. One, there are three major components. Hydrogen is odorless. It is colorless. When it burns in pure form, it's in the old, it is almost invisible. Those issues would have been of serious safety concern for a household, because you wouldn't know when the stove is lit or when it is off. We have achieved that when we light over flame now, it burns with a color. We have found a way to odorize the gas. So if there is a leak, you would smell it. So we have achieved that, and I said, for the top burners. So we have demonstrated in the lab, at UTECH, and also in homes. We have put this out in homes with a small group, and householders, housewives have cooked with it and have remarked that they have no problem in using the technology. For hydrogen, it is a bit safer than LPG. It is the lightest element that we know of. So on release, on escape, if there's a leak, it is going to your roof or to the outside. It does not stay around the stove like LPG, that on ignition will have an explosion. No. Secondly, our reinforced cylinder. If the worst case scenario, this will not explode like a metal cylinder. It will just burst the wrapping on the cylinder, because this is carbon fiber glass wrapping. So you won't have that massive missile going. You simply have a burst in it. They have tested these cylinders with bullets, with all sorts of things, and had found it anywhere as dangerous as a metal cylinder. And lastly, with metal hydride, this is the safest form we can have it, because it is contained within the metal hydride. It is pretty safe. On release, it's just a pressure hydrogen that is coming out. I don't think we can get anything safer than that at the moment.
The potential is great, much bigger than for cooking, and we should be looking towards the production of hydrogen using solar power to fuel our transportation system. There are also possibilities for introducing hydrogen gas into the electricity generation. And so the possibilities are endless. I think we just have to have a shared vision, and we need to work together, and I think we can make it happen.